In this video, we're going to look at how you would graph a tangent function using its phase shift in period. To start with, we're going to look at y equals 5 times the tangent of 3x plus pi over 4. And the first thing that we have to do is get this into standard form, which requires that we factor out the coefficient on x from both terms in the argument. So when I factor out this 3, I'll get 3 times the quantity x plus, and to factor 3 out of pi over 4, I have to divide it by 3, or multiply by a third. So this will be x plus pi over 12. And from here, I can compare this to the standard form of our equation, which should be a times the tangent of b quantity x minus h. Doing this, I can see that h here, negative h is pi over 12. So I know that h itself has to be minus pi over 12, and that's going to be my phase shift. The value of b is equal to 3. And for the tangent, I know that my period is always going to be the period of the standard tangent function, which is pi divided by b, which will give pi over 3. And remembering that the basic shape of my tangent function is centered at the origin with asymptotes on either side. From my phase shift, I'm always going to go left and right a half of a period. To get to my asymptotes, I'll need the half period. The half period is equal to pi over 6. Last thing, this 5, the value of a, is going to be a vertical stretch. So I've gotten the standard form, I've identified the 3 constants and their meanings here, and then I can start actually graphing my tangent function. So the first thing I need to do is I need to use the phase shift, which is minus pi over 12. And the phase shift is always going to move what normally lives at x equals 0 to x equals whatever the phase shift is. So I'll go to minus pi over 12 right here. And looking at my graph, what's normally at x equals 0 is an x-intercept. And I'll just kind of sketch in what I think the shape is going to look like right there. Again, this is at minus pi over 12. From there, I'll use the period to pick up the endpoints of my primary period. The endpoints in this case actually aren't on the graph, they're just the vertical asymptotes. So I'll have to go a half of a period left and right from negative pi over 12. So it might be useful to remember that pi over 6 is 2 pi over 12. I'll have to go that far to the right from here. 1 pi over 12 will put me at 0. 2 pi over 12 will put me at just plain old pi over 12. So that'll be the right-hand side of my primary period, which is going to be a vertical asymptote. Likewise, I'm going to go a half of a period to the left. Negative pi over 12 minus 2 pi over 12 will take me to minus 3 pi over 12. And that'll be the left side of my period, which again is vertical asymptote. And once I've done this, I just need to fit the shape. So I'll start at my x-intercept, go up to the right, following the asymptote. Likewise, I'll go down to the left and follow my asymptote. The last thing that I need to do is adjust for the vertical stretch. This has a vertical stretch of a factor of 5, and I'm going to show that always halfway between my x-intercept and one of my asymptotes. So halfway between negative pi over 12 and pi over 12, I've actually got the y-axis. And this location halfway between those is normally at y equal 1, but because of this vertical stretch, all my y values get multiplied by 5, and the y-intercept there would be 5. Looking at this, I've noticed that I don't have my coordinate here, so let's see, that was minus 3 pi over 12, and that would complete the graph of the tangent.